In this section, we will go through another routing algorithm called link state algorithm, LS algorithm. Link state algorithm is a very widely used routing algorithm. The basic idea behind LS routing algorithm consists of 5 parts. They are: step 1, discover its neighbors and learn their network addresses. Step 2, measure the delay or cost to each of its neighbors. Step 3, construct a packet telling all it has just learned. Step 4, send this packet to all the other routers. Step 5, compute the shortest path to every other router. We will go through all these 5 steps one by one. Learning about the neighbors. When a router is booted, it sends a special hello packet on each point-to-point line. The router on the other end is expected to send back a reply telling who it is using a global unique name. By doing this, every node can discover who are its neighbors. When 2 or more routers are connected by a LAN rather than a point-to-point line, the LAN can be modeled as a node. Measuring line cost. To determine the cost for a line, a router sends a special echo packet, and that the other side is required to send back immediately. By measuring the round-trip time, the sending router can get a reasonable estimate of delay. For even better results, the test can be conducted several times and the average can be used. The issue might be involved is whether we need to consider the load on the line. To factor the load in or not, both are reasonable. To factor the load in, the round-trip timer must be started when the echo packet is queued. To ignore the load, the timer should be started when the echo packets reach the front of the queue. Building link state packet. A link state packet should be constructed to send to other routers, telling them the information about its neighboring nodes. Information contained in the packet includes the ID of the sender, sequence number, age, lists of the neighbors, and delay to each neighbor. The next question is, when should a node build up a link state packet? It is a repeated task. State packet should be built periodically, or when some significant event occurs, such as a line or neighbor going down or coming back again. The diagram displays the link state packet for each node in the network topology. Let's take node C as the example to investigate. Besides the ID of C, sequence number, age, and the packet contains all its 3 neighbors and the delay to them. After link state packets are generated, the next task is to distribute this link state packet across the network to all the other nodes. The basic algorithm of distributing is explained now. Each state packet contains a sequence number that is incremented for each new packet sent. Routers keep track of all the source router sequence pair they see. When a new link state packet comes in, it is checked against the list of packets already seen. If it is new, it is forwarded on all lines except the one it arrived on, that is flooding. If it is duplicated, it is discarded. If a packet with sequence number lower than the highest one seen so far ever arrives. It is rejected as being obsoleted. The last step is to compute the new routes. A full set of linked state packets allows a router to construct a graph of the entire subnet. When we know the topology of the network and delay on each connection, we can now use Dijkstra's algorithm to figure out the shortest passes between routers. We can install this information in the routers to direct the packet. This is the process of setting up and maintaining routing tables. In the end of this section, we have a couple of questions related with the steps of distributing linked state packets in ALS routing. What can be the problem if we use the basic algorithm to distribute the linked state packet, and how the problem can be solved? Please think about it. That's it for this section. Thank you.